Hello, students, and welcome back. Welcome back to a real activity now. We are going together to perform, we're going to perform together the classroom activity on page 29 of your book. So I will provide you the materials and you will have to provide the observations. You're going to have to write things down and calculate things to determine the outcome of our classroom activity together. So if you turn to that page, the classroom activity, you will see what we are going to be doing. It says on the very top of the page what our problem is. Think about the scientific method. The problem reads, what is the density of water? Now, don't say it out loud. Don't say it out loud if you know. Many of you probably don't know yet, but you're going to find out by the end of this activity today. So the question is, the problem states, what is the density of water? Now, I want you to think of a couple things. First, as you know from previously, density is an expression of the mass per volume. So you're going to have some number attached to that density, and it's going to be followed by a specific unit of measurement. So I want you to consider, well, what is water? What state of matter is it? Is it a solid or a liquid? Hint, hint. Don't say it out loud. Think about it. What numerical value do you think if you take a certain amount of mass and divide it by a certain volume, what do you think the density of water is going to be, and how do you think it will be expressed as a number and a unit? And what I'd like you to do in your book on page 29 is to write a hypothesis beginning with the words, I think. Now, your hypothesis may be proven correct and it may be proven incorrect. That's okay. That's okay. That's why we're going to do this activity, this little experiment together. So again, the problem is asking you, what is the density of water? I want you to take a moment and write down what you think the answer to that problem is. What do you think the density of water is going to be? And I'm helping you out here. I'm trying to guide you along the way. You're beginning your hypothesis with the words, I think, and then you're going to write some number down followed by what you think the appropriate units are. Take a moment and do that now. Okay, hopefully you've had enough time to write down what you think the density of water is. And so now we're going to do a little experiment for our classroom activity. And you will notice in your observation section on page 29, you have this information. You have the mass of the empty graduate, the mass of the graduate and the water, and the mass of the water, followed by the volume of the water. And you've got lots of empty lines. You're going to be filling in these empty lines today with numbers in order that you will be able to calculate the density, which is all indicated on the bottom of your observation section. And I'm giving you the equation there. Remember that density equals mass divided by volume. Now, there are a series of steps in the procedures we're going to follow, and I'm going to perform those steps for you now. So it says measure and record the mass of the graduate. So I'm going to go over to our lab right now and perform this for us. So here is our close-up view of the lab. I have a graduate or a graduated cylinder. By the way, everybody, what does a graduate measure? Okay, it's volume. A graduated cylinder measures the volume of liquids. And I have a digital balance here. And what does a digital balance measure? Nice job. Mass, not weight, mass. And I also have a beaker of water, which is the substance we're going to be using to measure here today. Now, I fear you may not be able to see the readout on the digital balance, so I will help you out with those numbers. I will read them to you. But the first thing we need to do is turn on our digital balance by pressing the on button and waiting for the readout to read 0.0. And the units we use here are grams. So right now, we're measuring 0 grams because there's nothing on our digital balance. But step one of the procedures was to determine the mass of the graduate. So I'm going to place the graduate onto our digital balance. And I'm going to read the number there for you. And it says the mass of our graduate is 50 grams. 50 grams. So let's look at your data in your data table there. And the mass of the empty graduate is going to be written right here. 50 grams. Now, if you looked ahead, we're going to be doing 3 things. We're going to be using 3 different volumes, but we're going to be using the same empty graduate, the same graduate. So the mass of the graduate will not change. So you can write 50 grams here, here, and here, because we're using the same graduate, and the graduate has the same mass each time. All right, we ready for the next step? And by the way, all I'm doing is reading the steps right out of our book on page 29. So our next step is obtain exactly 25 milliliters of water in your graduate. So let's head back over to the close-up view here. And here we have our graduate. Here we have some water. And I am going to now pour, as exactly as I can, 25 milliliters of water. Now, whenever using a graduate, you want to make sure it's flat on a surface here. I'm going to move the digital balance a little bit out of the way here, just so I can center the graduate in the screen. I've actually used a marker to highlight the lines and the numbers on our graduate so we can see them a little bit better on the screen. And notice that I have the graduate flat on a lab table surface. Your eyeball, remember where your eyeball should be when reading a graduate. It should be level with the level of the liquid inside the graduate. Now, right now, that happens to be 0, so your eye should be way down at the bottom of the graduate until you start pouring some water into the graduate. And when you do that, again, that liquid forms a curved surface, and yell out if you remember the name of that curved surface, meniscus, and you want your eyeball to be level with the bottom of the meniscus. And as I'm reading that, it's a little bit shy of 25 milliliters, so we have to add a little bit more. And as I look at it now, oh, it's just a little bit too high. So we're going to take some of that water and pour it out. Yep. And we're going to look at it again. Oh, I poured out a little bit too much. So, whoop, there we go. Oh, and look at that. I'm looking at the bottom of the meniscus. Not sure if you can see that, but it is exactly 25 milliliters of water. Now, what is milliliters a measure of? Everybody, what are milliliters a measure of? Volume. That's right. So as we go back over here, and before we get to this information, you've given me the right answer. Milliliters is a measure of volume, but what's the next thing we're supposed to do? Well, we've obtained exactly 25 milliliters of the water. What is step 3? Step 3 reads, now measure and record the mass of the graduate and the water. So let's go back to the close-up view and check that out. So we're going to put, and by the way, we want to make sure that our digital balance is back to the 0 mark. So I push the 0 button. It's back to 0. So far, so good. And you remember that the mass of the empty graduate was 50 grams. So what do you think? What would be your prediction? Do you think it's going to be equal to, more than, or less than 50 grams when we put this onto the digital balance? Yell out your answer. What do you think? Hopefully you said more than, because we have added matter in the form of water into this graduate. So it would stand to reason there should be more mass. So let's find out what the mass now is. Well, look at that. It says 75 grams. 75 grams is the graduate and the water. So let's head back here. So we've got the mass of the graduate and the water. What did I say it was? 75 grams. Write down 75 grams there. And then we'll go on to the next step. It says calculate the mass of the 25 milliliters of water. Oh boy. How are we going to do that? How are we going to figure out the mass of the water if we know the mass of the empty graduate and we know the mass of the graduate and the water? How do you think we're going to find the mass of just the water? What mathematical function do you think we need to perform? Add, subtract, multiply, or divide? Yell it out. Subtraction. Very good. We're going to take the mass of the graduate and the water, which is the bigger number, and we're going to subtract the mass of the graduate, and that will equal the mass of just the water. So what numbers do we have? 75 minus 50. 75 minus 50. Now, if you don't have a calculator with you, that's okay. You have a calculator between your ears. And if the calculator between your ears needs a little visual aid, use some of the empty space on your page to write down 75 minus 50. And when you have an answer, yell it out. 25 grams. So in this space, you should be writing down 25 grams. And now let's go to the next step. Now it says calculate the density of water and use the correct units. Bum, 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 bum. So let's do that. What is density equal to? Density is equal to mass divided by volume. Mass divided by volume. So take the mass of the water and divide it by the volume of water. Well, wait a minute. What is the volume of water? We didn't write that down. Look at the top of the column. how much water were we supposed to put into the graduate? So what do you think is the volume of water? So the mass, 25 grams, divided by the volume, 25 milliliters, will give us the density of water in the units grams per milliliter. So what is 25 divided by 25? Call it out. Anything divided by itself is 1. So in this first trial, you got a density of water equal to 1 gram per milliliter. Be sure you write that down as we go to the next step. It says, now repeat steps using 50 milliliters of water, then 100 milliliters of water. Well, I'm going to help you out with the doing it again, but you are going to have to do the math on your own. So I'm going to collect the data for you, but you are going to have to fill in the rest of the blanks on your own. You already have the mass of the empty graduate all the way across. That has not changed. Now, I'm going to go back to our close-up view, and we're going to add another 25 milliliters. I love that sound, by the way. And wowie kazowie, look at that. I'm just turning it around so I can see the lines. I'm pretty good at this. I've done it for a while. I've gotten exactly 50 milliliters. That's the volume. 50 milliliters of liquid water in our graduate. I'm going to zero out the balance again. Wait for the 0.0. And then determine the mass of the empty graduate plus the water. And it is 100 grams. 100 grams. So go back to your table of values here, and we're in this space right here. The mass of the graduate plus the water is 100 grams. Think about how you're going to determine the mass of the water, the volume of water, and calculating your density. But before you do that, let's add more water to the graduate. This time, we're going to go all the way to 100 milliliters of water. Put your eyeball level with the liquid. Look at the bottom of the meniscus, and there we have it, 100 milliliters of water in our graduate. I'm going to zero out the balance again. We're going to determine its mass. And look at that. The mass is 150 grams. 150 grams. So let's go back to our data table. This was for 100 milliliters. The mass of the graduate plus the water is 150 grams. You have to fill in the rest of the information. So I have collected all of your data for you. What I would like you to do is to take the next few minutes to finish up your data table, make the necessary calculations, and then complete your conclusion. Once you've written your conclusion, then you're finished with this activity. And then I'd like you to go back to Google Classroom and complete the next item on the list. But for now, since I'm done collecting your data, I'm going to say bye-bye.